last talk, I know that you are super tired and maybe sleepy, so I will try to make it funnier as possible. The idea I will to show you my journey about trying to reverse engineer some iOS games, just for fun. Like, okay, you know, when you are just playing and just maybe frustrated, and it's like, okay, what can I do if I just reverse engineer the game, and what is the possibility to just bypass some feature and just create new features for you and have even more fun with the game. So that was my idea. First of all, who I am. My name is Alex. I'm known as Murphy as well. I'm a mobile researcher at Now Secure, yet another one. And I'm an R2Frida evangelist as well. I like it a lot. It's just a tool that actually I'm going to use it in some demos. That's the idea, just to combine R2 and the Frida world all together, and you will see how powerful it is. And that's my handler for almost everything, so you can find me just using that. That's the first thing. That's a big disclaimer, like, okay, I'm just going to teach you how to reverse engineer iOS games, but I don't want to create cheaters. Actually, we have some anti-cheaters around you, so be careful. That's our agenda. The idea is just to talk about a little bit Unity. How many of you have you coded some game on Unity? Just raise your hand. Okay, sweet. And in mobile? If you don't know, mostly all of the games in App Store, I said mostly, not all of them, of course, are coded using Unity. And if you don't know exactly what it is, that's what I'm going to show you right now. Actually, Unity is just cross-platform development. That's why it's so powerful. That's why it's so used across the community, not only for iOS, it's used as well for Android and for Windows. And the idea behind it is just because you code only one application, it's code on C#, and then when it's cross-compiled, with the same code, you are able to run exactly the same game on Android, on iOS, even on Windows. That's why it's so powerful. That's why it's so used. But I'm going to show you why as well. What is the caveats of using that kind of platforms as well? How is the build process working on iOS? How it is? So it's just Unity. When you code the C#, it's compiled to an intermediate language. That it's something derived from C#. I think it's proprietary for Unity, just something specific for it. And the idea then is just to compile it to C#, to C++, sorry. And this is compiled inside a library. Actually, for iOS, you can find this inside a framework that is called Unity Framework. And here it's where all the interesting part is found. Actually, this is the resume of what I already said. The idea is just you have the C# source code, there's a C# compiler, then it's creating some DLLs, then it's using some bytecode stripper, that is something internal for Unity, and with the stripper assemblies, like, okay, this is not even used, so I'm just going to use that part. I'm using IL to CPP, that is just some automatic process that is getting the intermediate language to C++. And then that C++ code is just compiled to create the application itself, and all the result is just here. So if you open one Unity application, that it's the IPA, it's just the format that iOS uses to distribute applications. In the end, it's just only a zip file. So you can just unzip the IPA. You're going to see all the files inside, and the important part is just the library. So you're going to find the main binary, that is the main binary for the application, but this binary doesn't have anything. So just have wrapper functions just to make the translation between the Objective-C wall or Swift wall to the code that you did, and it's inside the library itself. So this is how it looks like if you open an IPA, and then inside a folder that is called frameworks, you will find the framework itself, and this is exactly the piece of code that you are interested on. You need another piece, and it's because the cross-compiling process requires some metadata to do some reflection, or just it's something internal for Unity. And this metadata, it's even inside the IPA. Usually, you should be able to find it inside a file that it's called global metadata.dat, as you can see here. And this metadata is actually the function names, the arguments, the parameters, the return values. So it's like the information itself of what a method is actually doing. So quite useful if you're doing a reverse engineering process, because this is giving you a lot of information that you can use on your process. Some of games, unfortunately, they obfuscate it because they know how powerful is that information, so they are just trying to obfuscate it or encrypt it, so that's the plan. But this information should be there. So it's just a matter of time that you should be able to get this information. So here, for example, I'm using r2frida. That is just calling some Frida APIs to get the modules and the files and the maps created in memory. And if you look for the global metadata, and actually here what I'm doing is just listing all the memory maps, filter with the tilde for global metadata, it's the file name, and then I'm just filtering as well for the read-only sections. And just with that, I'm able to get where this file is found. And actually, if I xdump here 32 bytes to that direction, you should be able to see that content. So actually, this is a magic number that is always the same for this file. And if you, for some reasons, you are not able to find it, because maybe they just changed the name, that there are some games that are doing that kind of stuff, the only thing that you have to do is just look for the magic number in memory, and you should be able to get the map. And if you just dumped the content of memory to a file, you should be able to see exactly the same as the original one. So once we have this information, we have the Unity framework with all the code, we have the game binary as well, and as well, we have the global metadata. So only with these two pieces of information, and here I'm using one tool that is well known. When you are just looking for some information about reverse engineering on Unity, this is one of the most used tools for do this process. This is just making the pieces together just to create the DLLs, some decompilation, and some files with information that it's including the ILC2PP headers and all this metadata processed in a JSON file. So the idea is just to use this file that it's called script.json, and inside this file, it's where you should be able to see all the information that you need to reverse engineering, because there we should be able to find the name of the method, the arguments, the return value, and as well the address where you should be able to find the code that it's implementing that function. So there you go. We have it everything. So this is an example of how it looks like. It's just, as you see, the name, the signature, just the return values, and I mean, just with that, you have most of the work already done for you. So what am I going to do with this information? Okay, we have the Unity framework. We have the script.json. So we have the Unity framework that is the code, but it's stripped. So if you check it just with R2 with the command I, and we get information, we can see that it's stripped. So we don't have symbols, we don't have information, only on the binary. However, we have another file with all the information. Why not just put it together and see what happens? So here I'm using this script. It's already published. It's in the R2 GitHub. And this file is just a JavaScript file. It's pretty stupid if you see the code, and this code is thanks to Pancake as well. But the only thing it's doing is just processing the script.json file, getting the names, getting the addresses, and it's creating flags that is just marking all the methods inside the binary. So if you remember, we had the stripped binary, and just processing this information, we should be able to see this is the code. I'm just going to zoom in this method. So actually here, you have some idea of what it's doing without doing nothing. And actually here, you have how I use the script. That it's just a matter of opening the Unity framework, just run the script as a JSON file, and R2 have a JavaScript engine that is processing this internally, and there you go. You have all the flags inside the binary itself. Okay, thanks Pancake for the spoiler. But yeah, I'm using AI, as Pancake already showed. The idea is just, instead of explaining what is the R2 AI, what is the Kai, we are going to see a real example and a very useful use case where you should use, or you can use, just what Pancake showed this morning. So the first thing is just, with R2 AI, you should be able to communicate with different AI models, local or remotely, like Cloud, OpenAI, or whatever. And it's super easy to install. I'm actually using R2PM just to install it. But in the end, what I'm using is just the Kai. That is just, it's just a collaborative way to communicate between models. The main goal is just to enable some contributions from others just to train all together one model. But thanks to Pancake, we have a plugin just to communicate with all the different models that we have in internet or local, and getting all the input from the R2 session and just put it on the model itself. So how to configure it? Super easy, at least for me. It's because I'm just changing the API. I'm just using the one from Anthropic that it's called Cloud. And then I'm just using the lang. If you remember, Unity, it's code in C#. So I just want the result in C#. So once this is configured, the only thing that I have to do is just, okay, I'm just moving to the method itself, run the Kai-D, and that's all. And here you have some examples of real games, what you can get. So here, once everything is symbolicated with the script I previously mentioned, you can just decompile one method, and you have here, you know that this method, for example, just reading a little bit, you know actually what it's doing. So if you should be able to interact with this method, and you have a game that it's using gems for whatever, you can get free gems just interacting with this method. Or if you have a game that you're unable to run on a jailbroken device, by some reason it's like, okay, I don't know what's happening. Okay, maybe this method it's called, there's some interesting here, this is from another game, and you have exactly the checks, and it's almost super close to the original code that it's actually running. Okay, it's time for playing with the games. What I'm going to use? I'm going to use R2 Frida. I think you have heard a lot of R2 Frida, but no one's presented, right? So R2 Frida is just a tool. It's open source, it's inside this repo, and it's interacting, it's getting R2 session, and it's using the powerfulness of Frida just to interact all together on the same place. So the idea is that, for me at least, the most important part, especially for this talk, are the two latest features that I'm that are involved. That it just, I'm able to read memory. I'm able to disassemble the application in memory, and I'm able to modify the application in memory. So the idea is just, okay, I can use R2 as it should be a local file, but in the end, I'm just playing in memory. So if I crash the game, I can just restart it, and I can continue playing with it. And I can even call in methods. So I can just identify a function, that, like for example, the add gems function, and I can just use r2frida to call this function. And actually, if you remember, you know exactly the arguments expected by the function. So it's super straightforward. Like, okay, if it is expected a pointer, I just create a pointer with the expected output, and there you go. So, time for demo. I'm praying for the demo gods. And I expect to be like this at the end. So the first thing is, can we improve the game experience? I'm not saying cheating, okay? Let's see what we can do. So usually when you are playing with these kind of games, they are expecting some special inputs when you're calling methods or whatever. One example is like, okay, I just want to call a method that is implemented in a controller, but this method is an instance method, so I need actually a reference to that controller. How it's possible to get this reference? So maybe there are a lot of ways to do it, but this is the one I found that for me was easier. That it's like, okay, I'm just going to hook the method that it's called pause, and just put a breakpoint, and then I'm just going to get the reference, just getting the x0 value. So this is like actually a real pointer in memory that it's pointing to the game controller instance that then once I get it, actually I can use it for whatever I want. So let's see how it goes. So this is the script, the JSON file. Here we have the pause method. Just going to, and I'm just going to plop, run a game. Okay. This is the way to use r2frida to attach to a process. I'm just using USB, and this is actually the process name, that it's a random game. So then what we need, the first thing we need is just a reference to the Unity framework, because we are actually using the Unity framework, but we need to rebase all the addresses with where it's been loaded. So I'm just going to filter out Unity, and so this is filtering the output, and I'm just filtering for the Unity framework, just getting the map with read and execution permissions. So actually, I'm just going to put this inside a flag, just to remember it, and avoid to have it to run it again and again and again. And then I'm just going to get the pause method, just getting the address, and get the base address plus that value. So actually, this is the method that is implementing that method. So I'm just going to create a breakpoint. All the r2frida commands, if you see, are preceded by a colon at the beginning. So that's the difference between the r2 wall and the frida wall. So I'm just going to put a breakpoint and resume the game, pause it, boom, I have the breakpoint hit. So I'm just going to list all the registers, and with the dot at the end, it's just to list all the registers of the current thread. Just going to get it, And if you remember, the interested one is just x0 that I'm not able to see. There you go. And actually, I'm just going to plop, put it in a flag. I'm lazy. So actually, if you see, the game is frozen. So it's waiting for someone just to resume the process. So if I click DC, just continuing. So the breakpoint, it's not hit it anymore. So I'm just going to remove the breakpoint just to avoid being noisy. And we are going to see what we should be able to do with the game controller. So I don't know if you know the game, that is a temple run, that is just a guy running. So I found a method that is called boost player. What is going to happen? I don't know. Let's try it. So let me just look in here, boost player. There you go. So actually, these are the arguments expected by the method. It's just the game controller itself. If you remember, I already got it. It's just looking for a distance and a bool and another pointer that actually you can ignore. So something that we can do is just, okay, I'm just moving to the method. This is a r2 instance. This is statically. This is just the Unity framework already symbolicated, opened, and emulated, just to get all the reference calculated. And then here you have all the code. And this is actually the boost player. That is the same method I was looking for. I'm just going to use the chi because I don't want to read the disassembly and see what's the result. So just to try to understand what is the method doing under the hood. So the internet is quite slow, so just be patient. As you can see, be patient. There you go. So here you have, in real time, a compilation of the function itself. You have the arguments. This is just the game controller. And it's funny because the distance method, that it should be that one, anyone is able to find where it's used? It's not even used. So why I have to be worried about this parameter if it's not even used? So actually, we only need the argument 1. That is what we are going to use. So let's continue just getting the reference to the boost player. If you remember, I have to rebase it again. I'm just getting the pointer. Here, and just putting the game just to see that I'm not cheating. Okay, you can see the guy there, just running out of monkeys. And now I'm just going to call this method, but if you remember, I'm just going to use the game controller. But this is just the game controller I saved inside the flag. This is just the hack that I used to use exactly the same value. And if I resume the game, choo. So actually, it's just a matter of, okay, I can play all the time I want. All right, this is fun. We know exactly how to do this, but it's not enough. As you see, I died, so it's just pressing all the time. I'm lazy, remember, so I just want to play without even touching anything if it's possible. Let's continue. There are some obstacles on the game that you're going to crash. Why not just avoiding them by default? So here, the way I use it's quite different. I'm not just calling a method. The only thing is just, I'm just getting the method that is handling the obstacles, and then just overwriting the beginning. If you remember, I can disassemble the method, and I can even modify the instructions inside the method. Why not just return and do nothing? Let's see what happens. So let's look for game controller, handler, how was the name? Handler collisions. It's just right here. So I'm just going to move to the method and just run PD5 just to disassemble the method. You can see some instructions here. And what I'm going to do is just write a return instruction. If I disassemble again, oh, sorry, you have the instruction here. So actually, right now, every time that the game is just trying to handle a collision, what's going to happen? Let's see. So okay, I'm just going to swipe. This is a tutorial because I had to reinstall the. That's the AI. It's only the word for another one. But it's not enough. As you remember, you can die. Why, if I just get the method that is handling the end of the game and just do nothing? And as well, I found another method that is it's called resurrect. It's like, okay, I can play all my life the same game and never ends. That's super good because I can just leave the game and continue tomorrow, the same game. Sorry. Okay. I'm super bad with memory, so let's see. Game controller, handle, and game. Actually, here I'm just combining the two different strategies. Like, okay, I'm just adding the return value just to do nothing, and then I'm just going to call a method just to do some specific stuff from the game. So let's just calculate this stuff again, move it. This is actually the method that it's not this. It's not this one, right? Thank you. And the idea is just to repeat exactly the same process. So we are just going to return. And then just look for the other method that it's called game controller, resurrect, there you go. I'm just going to prepare the command. Sorry if I'm slow, I need another coffee. So right now, I'm just going to resume the game. Okay. Just going to die. Boom. Okay, this is because it's a tutorial. Just let me finish it. It's super funny. Huh? Not really. Yeah, it's because the tutorial is like, okay. Now it's just going to start. Okay. Now it's like frozen. Just going to click. Boom. I can play again. So right now you can play all your life if you want. But it's not enough. So in games, okay, that means that I have to play. So, okay, now I can play all my life, it's not ending, but why if I can just get extra coins? So instead of just getting one value per each coin, why not just multiplying per 100, 1,000, or whatever? Here, actually, the only thing I'm doing is just, okay, I'm just getting the method that it's called add coins. I'm just doing a decompilation of the method. I see that at the beginning, if you can see that it's in purple, at the beginning, it's just doing some check. Like, okay, if the value is less than 1, just return and do nothing. So I'm just going to remove this condition, and I'm just going to add it. I add a move, like, okay, instead of 1 coin, just put the value that you want. So, okay, this method is different. So this is the method. I'm just getting the value of the method. Just going to reverse it again. As you can see, it's quite straightforward once you get exactly how to do stuff. Just going to move to the method. Here you have the 2 instructions that I mentioned. So why not just, I'm just doing the comma because I'm going to write some main instructions on this memory position. So I'm just going to write move 100, I think it's fine. I'm just going to write a knob just to avoid the branch. As you can see the result here, you have the move and the knob on top. I have to resurrect it again. And just check the coins, that it's just the value. So now it's easier. Yeah, why not? Yeah. So, this is actually what we did. It's just, as you see, that's how r2con is powerful. It's just, you can disassemble in memory, you can see the instructions, and if you know exactly what you're doing, you can modify the instructions and do whatever you want. But it's not enough. Because this requires to analyze one game. But I'm lazy, remember. What if I can get, why if I want to get resources from all the games only with one shot? That's possible? So if you know what is an in-app purchase, it's just a process that all the games, or mostly of the games are having, that it's like, okay, the game is free, but if you want to get adding gems or just extra coins, you have to pay. And it's like, okay, just pay €1 for, I don't know, 100 coins. And I said, okay, yeah, it's fine, but I'm not rich. So this is the process, actually, that it's involved when you are doing a purchase. That in the end, it's like, okay, this is the game, it's just making a request to the App Store. Then you get the pop-up like, hey, do you want to pay I don't know, 100 euros per this purchase? And you say yes. And then the game is just validating the transaction with the game server. The game server says yes. That guy that is checking the stuff with the App Store is saying yes. That guy paid 100 euros for this transaction, so just give him all the coins he asked. And it's like, okay. But do you think that all the games are doing that server-side checking? Let's see. The answer is no, obviously. So actually, it's like, okay, they are just making the request to the App Store, and then it's just waiting for some response like, hey, the purchase has been done, and the game is like, it's just happy and says, okay, thank you. Give you the coins. So this is an example of a decompilation of a game, just to see that if the purchase is correct, it's just depending on the type of the purchase, it's just disabling the ads, giving the gems, or give infinity pack. But it's doing nothing. I mean, it's not validating nothing. So what could go wrong? So here I have another game. Boom. This is what it's an in-app purchase. Let's buy some stuff. That's making just a request to the App Store. It's slower because the internet here it's kind of creepy. But there you go. No. Well, I can pay. Let me check. So I'm just going to run a Frida script. This is actually Frida. It's a Frida JavaScript. And actually, I'm using r2frida with this, with the dot at the beginning, just to load the Frida script and use it inside that session. So actually, what the Frida script does is just pretending that the purchase has been done successfully. And it's just modifying some stuff. It's quite slow. But yeah, I mean, it's worth. It's $3. That's a good thing. Okay, from 5 demos, just failing 1. It's fine, right? There you go. So, finger crossed. Anyone has $3 to lend me? I'm just going to cancel the purchase. Boop. Boom. So, wrapping up. We learned how to reverse engineer Unity games. We know exactly how to use the metadata from the games itself and make some fun. The important part is just the feature. I mean, this is something that I did on my free time as well. But there are some games that are doing better, the stuff, like protecting the metadata, obfuscating it. There is some literature in internet related to how to get it. There are some tools that they are not open source, so it's like, or you use it or just forget it. My idea is just to implement all this stuff, if it's possible, using R2. Like, okay, I'm just going to try to get how to decrypt it, how to defuscate it, and even I'm just working on trying to get rid of the IL2CPP dumper, because it's a tool that it's mainly used on Windows. I don't like Windows, so it's like, okay, I don't want to use it anymore. I'm just, unfortunately, it's open source, so I'm able to get the logic and implement it on R2 side. So actually, I'm working on just creating a script to do it everything with R2 if possible. That's the plan. So that's it. Thank you.
Any question, cheaters? I'm afraid right now of these guys. Edu.
Remember the disclaimer.
Well, thank you for the talk. I have one question. It's about the AI. So how was the compilation of Swift before the AI? I mean, it has been improving a lot, or it was different?
So now it's of Swift?
Yeah, Swift.
So instead of C#, using Swift, you mean?
No, instead of using the AI, right, the plugin that you were using, how was the compilation before? I mean, it was similar, it has improved. I mean, I don't do much iOS.
I don't know. Yeah, it's like, okay, just getting the compilation using PDC, then put it on Cloud, and it's like, okay, just rewriting with the variables names that it's getting and the method name that it's getting as well from the metadata, and it's just trying to make, as he said,
it was not as clear as it is now, right? It was not that clear.
It wasn't even a high-level language. It wasn't even a high-level language. It was PDC, which is a kind of pseudocode. It's not even a decompile.
So actually, if you use IL2CPP dumper, you're getting the compilation, but sometimes, I mean, you're getting something like, okay, the method is doing something like this, but it's like an idea. And sometimes the compilation is not complete, and sometimes as well, you don't have the compilation itself. It's like it looks like the method is empty, but in the end it's not. So the code is there. So that's why I don't like that tool, because for me it was incomplete in terms of, okay, once if the compilation is empty, what should I do? I don't know. Like with this method, I'm able, once I get it working on an application, as you see, it's just a terms of have fun, because you can do whatever you want on the game.
And another question is, have you reached the #1 in the scoreboard? I mean,
Fortunately, I closed the application before uploading the score. But yeah, you can do it.
Yeah, one question here. I saw that you extracted all these symbols from the metadata and then imported those. How common is that you find all the symbols shipped with the apps? Because I suspect that games shouldn't be shipping the symbols with the package application.
This is a thing from Unity. So by some reason, I don't know exactly why. Maybe it's some reflection or whatever, but I think it's the price you have to pay to have one code working for all the platforms.
But can they strip that from the distributed package?
From what I've seen, nope.
Okay. Yeah.
So I've seen obfuscation. I've seen.
Yeah, but I guess obfuscation of
encryption.
symbols pre-building.
Last question is the global metadata that file contains actually types, structs, and also.
Thank you.
And yeah, not a question, but I just pushed a commit that it's updating the script to add the base address, so you don't need to add it all the time.
So I don't think we'll find any other conference in the world that during the talk someone is like pushing to the repo to fix shit. Okay, that's good. That's good. I was near to him like, what the fuck are you doing? No, I'm fixing that. I was like, during the talk. Okay, thank you very much.
Thank you, Pancake.
Any other questions or PR? Okay, thank you, Alex.
Thank
you
you
very much.